Hi everyone, and welcome to the final session here at Public Sector Summit Canberra. I hope you've had a really awesome couple of days if you attended any of our pre-event day events yesterday. And I hope you've seen some of the excellent sessions that have been available to everyone today. I've seen a few of them myself, really high quality. I know I'm keeping you away from the networking drinks at the end of the session, but stick with us for half an hour and I hope you'll learn some interesting visualization and voice enablement tools you can use for security. Now, before I go into this, I just want to show you something I've got here. Now, did that get your attention? Well, I hope it did, because otherwise I'll set it off again and I'll walk around the audience. Now, just ask yourself, why did that get your attention? It's because humans have evolved to react to visual and audible cues. We look for patterns, we look towards a strobe light, it gets our attention, and alarming sounds, they just make us look around. So what's happening? Where's that sound coming from? Now, what we want to talk to you today about is how can you harness these two sensors with security on the AWS platform? Well, first of all, let's go back to what you don't get. So this is what logging looks like. So logging sources come from a lot of different areas, machine-readable formats, not human-friendly, a lot of information coming in, and I'm sure you've all followed our security best practices already. You're sending all your logs to an S3 bucket in another account. You've turned on all your logging, CloudTrail, config, CloudWatch logs. It's great, perfect, lots of logging information. So what can you do with that? So this is what it looks like. It's like none of that calls out to you, this needs my attention, something's going wrong, there's a fire burning, what can you do? Well, I'm glad you asked. Visualize your logs. I'm going to run you through a few common patterns you can use and then one new one to visualize your logging information on the AWS platform. So first of all, what options are available? Well, first of all, what we have is customers typically deploying Amazon Elasticsearch and using Kibana. So this is fully managed service built using the Elasticsearch project and using Kibana as your visualization dashboard. And what we typically see customers who deploy this in one of two ways in AWS. First of all, they build what we call the EKK Stack. And this is Elasticsearch Logstash for ingesting and sending your logging data into your Elasticsearch cluster, and Kibana for the visualization. In the last few years, we've also seen customers build the EKK Stack. And this is replacing Logstash with Amazon Kinesis Data Firehose, fully managed serverless service again on our platform. You can ingest, buffer, process streaming data, and then send it out to other services or, for example, into S3, which I'll show you today. However, I want to talk to you about a different pattern. And this can be set up easily in minutes. First component of this will be using a relatively new service, Amazon Athena. Amazon Athena is a fully managed service that allows you to execute standard SQL queries against data stored in an S3 bucket. Very powerful. You just pay for the execution of the queries that you run. And it also has a number of nifty features with the way you store your data in the S3 bucket. So you can use something like Apache Parquet format. And you can also compress your data with gzip. So you're actually paying minimal S3 storage charges. And if you partition your data in an optimal way, your SQL queries in Athena will execute faster. For visualization, we're going to use Amazon QuickSight, another fairly new product. It's our cloud-based business intelligence visualization tool. And it allows you to connect to multiple AWS services and other third-party applications and products, which I'll show you in a minute in the console. And very quickly build analysis dashboards from the feeds of services like Athena, or directly from S3 or S3 Analytics and so on. And then publish those dashboards out to users in your organization. So that's great, you might be asking yourself. You say, Michael, I'm not a DBA. I don't know how to work with SQL. I don't know how to set up a query database table schema for Athena for my data stored in an S3 bucket. Well, it's really easy. We've already published sample query database table schemas for you to work with Amazon CloudFront logs, Amazon AWS CloudTrail logs, and also for Elastic load balancing. However, I want to talk to you today about a different log source, and this is VPC flow logs for our security focus. VPC flow logs capture all your ingress and egress traffic at the VPC level or lower in an account. You can enable it at VPC level, you can enable it at per subnet, or you can enable it at Elastic Network Interface level. I highly recommend, however, that you do enable it at each VPC in all of your accounts as part of your best practice security hygiene. So, as part of the process of enabling VPC flow logs, we set up a destination in CloudWatch logs. Then, I'm going to have a Lambda function subscribed to that CloudWatch log source, and it will be streaming our data into a Kinesis data Firehouse stream. Now, you do have the option, as of a few weeks ago, to directly pass data from VPC flow logs to an S3 bucket, which is going to be our final destination in this demonstration. However, what I want to also do is add it, while it's passing through the Kinesis data Firehouse stream, is run a second Lambda decorator function. It's going to add some more details to the standard VPC flow log data that's streaming through, such as the direction of traffic, inbound or outbound, security groups from an EC2 describe call, and also some geospatial information, such as latitude and longitude, and city and country of the source IP address. So once that is passed through my Lambda decorator function in the stream, it's passed back down into Kinesis data Firehose, and this delivers it in compressed gzip format into my S3 bucket. From there, I've set up my query database table in Athena, connected directly to this S3 bucket source, and then I can execute SQL queries immediately against that data. And finally, for the visualization piece, linked to Amazon QuickSight. I'm now going to show you how this looks in the console and show you how easy it is to use. So, hopefully. Yep, awesome. Okay, so first of all, I'm just going to show you how you set up VPC flow logging in an account. So you just go into VPC settings, select your VPC over here, and down here, go to Flow Logs tab, and click on Create Flow Log. By default, it will choose to filter on all accepted traffic, but I would recommend, for security purposes, you're capturing all traffic. And as I mentioned earlier, you can send to an S3 bucket, or send to a CloudWatch log source. Specify your destination log group in CloudWatch, and the IAM role for sending it to CloudWatch, and then simply create. I've already got one created for this demo, so I'll just jump back to show you. So you'll see here, at the bottom, we've already got a flow logs, CloudWatch log destination created. And if I go to that in CloudWatch, and you'll see, although it's capturing at the VPC level, it will then divide the log information at the ENI level in the log for you. And just to show you that it's capturing the VPC flow log info that we expect, this is standard VPC flow log information, so we're getting source and destination IP address, the account it came from, the ENI that it passed through, ports, time, start and end for the packets in epoch time, and whether it was accepted or rejected. Using the Lambda function, this is actually being passed to VPC flow logs to S3 bucket Kinesis data Firehose stream. And if I just scroll down for you, we've got a Lambda function, which is the decorator function, attached here. So as it processes through, streaming in near real time at the data through CloudWatch logs, this Lambda decorator function is then going to add the extra information for us. Lambda function as per this, so it's just attached directly to our CloudWatch log, to our Kinesis data Firehose. And it's a simple function. All it does is add in some extra information, passes it into a particular format that I want to use, and it then does a lookout to the internet to a geospatial web provider, which will then give me back country code information, city code, and latitude and longitude information. Finally, it then passes that back into the stream and repackages it and zips it for me. How this looks when it is delivered to the S3 bucket is like so. So you'll see up here, as it gets delivered, it's already partitioning it for me into year, month, day, and hour. If I was using the Parquet format, I could partition that further. And then you just have your gzip files being stored here. So I'll just move across the Athena console to show you how we work with this in Athena. And it's really easy. Setting up a table to query your data, you connect to your S3 bucket source. So I'll just show you the properties. So we have this string summit bucket, and that's where our VPC flow log information is being delivered to. And then we create a table which simply defines each of the normal fields you would expect in VPC flow log, along with the extra information that we're adding, such as security groups and direction of traffic. And you can simply make sure that it's working for you by just doing a quick preview table in here in the console. And as you can see, it's very similar at the start to the same information you were seeing earlier in CloudWatch logs, except we now have the extra information here of security group IDs, direction of traffic, and some country information. You can also execute standard SQL queries, as I said earlier, straight against this data. So I've got a saved query here, which I'll bring up. So this will bring us the top 25 connections to SSH for that VPC flow log data. And as you can see, it's just a standard SQL query. Run that query for us. This will take a few seconds, hopefully not too long. It varies in my data set from about 5 seconds to 14 seconds, depending on the connection. And when it comes back with the data set, we'll get a top 25 list with the count for IP address of the connections to SSH from that data. We're running a bit longer this time, unfortunately. All right, there we go. So there's our count, source address, and from that current logging information, someone hitting that from that particular IP address with 26 times in that sample. But you can save other structured queries here if you want to, and keep them in a library for Athena. However, I'm just going to move you over now to QuickSight, and this is where we build the visualization connected to Athena as a service. Now, this is the main landing page dashboard. First of all, you would come up here and choose Manage Data. I've already got my data set connected for Athena here. And if I bring that up, you'll see it refers to Spice. And this is the superfast parallel in-memory calculation engine, which is built into QuickSight. And this will actually read in all the data on a query from your connected data source into memory in a cluster and built into the QuickSight service. And it allows you to execute thousands of simultaneous queries against that data from different users. If I bring up the data set, you'll see how simple it is. Once it's connected to Athena in this case, it simply brings up all of the fields that are available to you in that table, as defined earlier, here on the left. And you just need to just choose the ones that you want to have visualized in your dashboards, and it will give you a quick sample here at the bottom. So I've already done this, but one thing I will show you is just if you do a new data set, just the options that are available out of the box for QuickSight in the console. So as well as AWS services such as S3, Athena, and RDS, you can directly connect to database services as well, such as SQL Server, MySQL, and Postgres. Connect to Presto and Spark, Teradata sources, GitHub, Jira, Twitter as a feed. And so we have customers who are visualizing sentiment analysis from their Twitter feeds, ServiceNow and Adobe Analytics for their websites. We're using Athena in this case. So I'll go back, and once you've created your data set, you then need to create an analysis. So I have one here pre-configured. And this is where you set up your charts and graphs from the data that you have. Over here on the left, you get to choose your visualization tools, the fields that you want to visualize, and then you choose your chart types here. Depending on the type of data, you can do different types of visualizations. So there's even a geospatial one here, which I haven't got configured today, but it will allow you to bring up map information and so on. You can bring up bar charts, pie charts, etc. Whatever suits your data field. And up here, you choose your field wells for your X and Y axis of information, the values you want to display, and then you can adjust the colors and so on. You can also set up a number of filters on your charts. So say you want to exclude or include only certain IP addresses or certain information here. And then once you're happy with the charts you've created, and in my case I've created 2 sets, you just come up here onto the top right and choose Share. And this is where you publish your dashboard out to users just a set of IAM users across your AWS accounts. And then they get a read-only copy of this analysis that they can work with. So I'll just jump back to a dashboard, just to show you what this looks like. Okay. Now I'm just going to walk you through a security story with the two dashboards which we've created here. I'll just maximize that for us. So what we're seeing here is inbound traffic to web servers in my AWS account. So far, so good. If we drill down a little bit, we'll see what kind of destination ports this traffic is coming to. Now, the majority is coming to port 80 and a bit into 443. That's fine. They are WordPress servers. We'd expect that. But disconcertingly, we're seeing a lot of traffic coming into port 22 for SSH as well, which shouldn't be open. If we drill down a little bit further to see where that traffic's hitting, we'll see it's coming into particular security groups. So to filter on those security groups in particular, we'll jump to the second chart. I'll make that a bit bigger. So, okay. So this is ranking number of packets coming in from particular source IP addresses by country on the first chart for this security group, which is allowing web ingress access to our web servers. And then, if we have a look here, this is the ports that are being hit, and we can see port 22 there standing out in red. So, if we go back to our VPC console, and we have a look at our security groups, we'll see indeed for our WordPress group up here, and we have a look at our inbound rules. Indeed, someone has actually opened port 22, so we know there's a security issue, and we can really remove that. So that's just a sample of the kind of things that you can do with the visualization tools built into the console with Amazon Athena for analysis and QuickSight for visual tools. What I would like to now do is hand over to my colleague, Sumit Patel, and he's going to show you how you can voice enable some of your security checking. All right.
Awesome. Thank you, Michael. So Michael has shown you how visualization can help you understand what's happening in your AWS accounts. I'm now going to touch on how voice can do the same as well. All right, so let's start off with a scenario. Let's say you are the head of security, and the first thing you do each morning is log into your computer and check whether your production workloads are secure or not. Now, that's a bit cumbersome. How about if we use our Amazon Alexa skill? So we've built an Amazon Alexa skill that allows me to check whether my production workloads are secure or not. Let me show you how that works. Now, typically I would have an Echo device with me, which is this in the back here. But as of a few weeks ago, Alexa is now supported on the mobile phone. So I'll bring up the Alexa app that's there, and I can actually talk to it. Alexa, open cloud security. Oh, let me try that again. Alexa, open cloud security.
Welcome to Cloud Security Skill. How can I help you today?
Check if my production workloads are secure.
Okay, I am checking if your production workload is compliant at this point in time. Give me a second. Okay, I have found that 3 out of the 18 CIS benchmark checks non-compliant. Did you want me to read them out to you?
Yes, read them out.
Okay, firstly, MFA on root account is not turned on. Next, IAM password policy requirements are not met. Finally, VPC flow logs is not turned on. I have also sent you an email of these results.
Awesome. So you can see how the power of voice can vastly improve that experience of understanding what's happening in your AWS account. This is not to replace that visual platform that you have, but to supplement it. Okay, so let's now talk about how we've built this. Firstly, we've got to understand what is secure and what is not. So for my solution, I use the Center for Internet Security benchmarks. So these are industry standards defined by experts, and an example of them is turning on VPC flow logging, as Michael has shown you earlier. We have an excellent quick start available in that link there behind me. where you can quickly deploy these CIS benchmarks into your own AWS account. So if you're looking for security best practices to start off with, check out that link there. Now, my resources are continuously changing. So I've got my security best practices that I want to align with the CIS benchmarks, but I need to track it against the AWS services, and that's where config comes in. So config allows me to track changes across all my AWS services, and you can use it for governance, you can use it for change management, or for simply inventory of what's happening in your AWS account. So config runs against, as I said, across, I shouldn't say all services, but most of the services, and examples of them are EC2 and S3. Config also, as of a couple of months back, is now supported across multiple accounts. Highly recommend you check out config and turn it on in your own AWS account if you have not already done so. So on top of config, there's config rules. And so config rules, you can think of them as bringing those CIS benchmarks and plugging it into config service itself. So that VPC flow logging to be enabled, that's a config rule. And with these config rules, I can then have an action out of that, whether that's to notify me, whether it's compliant or not, or to take an action out of another action that you define, maybe to remediate or revert the change. So here's a screen grab from the config console. So if you recall from the Alexa skill, it called out 3 non-compliant resources, so you can see them at the bottom there. In the config console, you can drill deeper into each one of them and see what that resource is, when it became non-compliant, and by whom as well. Finally, we need to bring this solution, the security solution, into my Alexa skill, right? And so for that, there's 2 parts to it. There's the voice user interface, where I define what my request and response is going to be. And then there's the programming logic, which is effectively a Lambda function, which where I've defined how I'm going to handle those responses, requests, and then interact with my backend AWS services, which in our case is config. So here's an architecture diagram of the solution. So from left to right, we've got an Alexa skill where I'm passing on my request. Lambda function then pulls the results out of AWS config service. And our AWS config service has those CIS benchmarks through the AWS config rules. So all that is then pulled through, and we get that response on my Alexa device, which in my case was my mobile phone. Okay, so I've shown you an example of how you can do a point-in-time check, but if there's a security breach in your organization, you want to know right away, right? So we're going to touch on that in the next scenario. So let's say you have a Amazon S3 bucket, and you hold sensitive customer data in that. Now, you've got the necessary permissions to restrict who can do what, but your admins, knowingly or unknowingly, may expose a few of those objects in that sensitive bucket out to the internet. So you want to know right away when that happens. So let's drill deeper on the scenario. So as you can see here, I've got 2 S3 buckets. So the one we're going to focus on is our private bucket, which is, as you can see on the access level, is showing as not public. So what could an admin do? They could do 2 things. They could try to upload an object with the public read ACL, API call. And by the way, they could also do this through the console. Or they might try to change permissions on an object with a put object ACL API call with the public read parameter. So what do we need? Well, we need a timely response system. And we don't want to leave those objects exposed out to the public waiting for us to act on it. That's the power of AWS. We can actually automatically revert those permissions back to private. So when it comes to notifications, many of you may use social collaboration tools such as Slack, or you may use a pager, or you may use email. But what I find is that when I'm getting notifications sent through to my phone, I don't get to it in time, or I might miss it altogether. However, if I get a phone call, and if I recognize who that phone's coming in from, I'm very likely to pick it up. So I know if my wife calls me twice in a row, I'm picking it up. There's something not going well. All right, so what I want to do is show you a demo of this solution, and then we'll talk about how I've built it. So can we switch to the console? Cool. So you can see the two S3 buckets that I've got here. So we'll go into my private bucket. Let's say I'm an admin that's just been sacked, and I'm going to expose the secret file out to the public. So we're going to hit make public. I'll keep my phone close to me so you can hear it. So it comes through. Oops. It's taking a bit longer than it used to. I'll refresh it again. Let's try that again. Optus network. Ah, there you go. Cool. Put that on speaker. Hello? Okay, looks like there's some network problems. Can we actually just switch to the connect? Oh, actually, let me pick that up. Let's bring up the other one. No, yeah, let's switch to the connect demo. I've got a video recording of this as well. Okay, so you got it up there. Cool. So you can see I'm basically making that permission, making that object public. I'm hitting save on it. So you'll see now that the permissions actually have been reverted back to private, and then I get a phone call. This is what should have happened.
Warning, warning. S3 bucket, 6 on a key private, has had an attempt to expose a file to the public. I've gone ahead and reverted the permissions to private. If you would like me to open a support ticket to the security team, please choose a severity between 1 and 3, with 3 being the highest. I have opened a high priority support ticket to the security team to investigate right away. Thank you, and goodbye.
Awesome. So you could see I could revert the permissions back, and then it called me, allowed me to also open a support ticket to the service team. Obviously, one requirement on there is to have good network. All right, so let's talk about how we've built this. The solution's effectively built off 3 parts. The first is Amazon Connect. So Amazon Connect is a service that allows you to build a call center in the cloud. The great thing about Amazon Connect is the API that's exposed by it. So for my solution, I needed an outbound call to my phone, and so I used the API with the outbound call support. And the other part to Amazon Connect is the integration with the wider AWS ecosystem. So I'm also tying in back to a Lambda function, which I'm going to touch on soon. Secondly, we need to capture the 2 events. So this is the reason why I talked about the put object ACL and put object earlier. So if you're doing it through the console or through the CLI, those are the 2 events that I'm interested in, and the S3 bucket that I want to filter down on. So for that, I need to turn on CloudTrail, which logs my API calls being made across my AWS account. And then I can define a CloudWatch events rule. So you can see the JSON doc on the right, where I've defined those parameters. And finally, I need a Lambda function. So Lambda function is where all the magic happens. So there's 2 parts to it. I've got the remediation, which is to revert that permission back to private, and then initiate that outbound call, which is to use connect and then call me and allow me to open up a support ticket as well. So you can see just with a few lines of code, I can build a pretty effective security notification remediation solution. So let's walk through the architecture. So user will try to upload or change permissions on an object in a bucket. We'll have that CloudWatch events rule, which catches that event and triggers AWS Lambda function. Lambda function does 2 things. It reverts the permissions back to private on the objects in the S3 bucket, and then it initiates Amazon Connect, where it alerts me, notifies me, and allows me to also open a support ticket. All right, so that brings us to the end of our session. So just to recap, I hope you can start to see how services such as QuickSight and Alexa and Connect And we've talked about a whole bunch of services actually here today. But with a combination of this, you can build pretty effective, innovative, and serverless. Right? So serverless meaning it's cost-effective as well. Security solutions. We hope you can take some of these back to your own organizations and build them out in your own accounts. So here's our email addresses. We'll also be sticking around here, so if you do have any questions, feel free to come and ask us. Also, don't forget to swipe. I believe you can actually scan your badge, and you'll get the links as well of some of the content that we've talked about. Thank you very much for being here today at Canberra Public Sector Summit. We hope you come back here again next time. Thank you.